Now that we know how different angles and parallel lines are related to one another, we can use what we've learned to establish some interesting information about triangles. For example, the sum of the angles of a triangle is equal to 180 degrees. Let's find out why. We're going to start off with this given triangle, triangle ABC. Let's draw a line through point B that is parallel to line AC. So we had our triangle, there's point B, so we're going to draw a line through it to make it parallel to the opposite side AC. And then if we number the angles in our triangle, 1, 2, 3, and then a few extra angles outside of the triangle, such as angle 4 and 5. Now we're going to use what we know to prove that the sum of the interior angles of a triangle equals 180 degrees. Well, the first thing that we can say is that angle 3 and angle 4 are congruent to one another, because if two parallel lines are cut by a transversal, then the alternate interior angles are congruent. So our transversal is line P, angle 3 and 4 are on opposite sides of it, and they are inside of our two parallel lines K and M. Using similar strategies, we can also say that the measurement of angle 5 out here is congruent to the measure of angle 1 plus the measurement of angle 4, because these two smaller angles form the bigger obtuse angle that is alternate interior to angle 5. So because we have two parallel lines cut by this transversal, line N, these two alternate interior angles are congruent. We also know that angle 2 is supplementary with angle 5 because they are supplementary angles that are adjacent to one another. So what we can do is we can add up angle 2 and angle 5 and set it equal to 180 degrees. Because together they are supplementary angles that form a straight angle. And then, because we know that angle 5 is equal to the measures of 1 and 4 together, we can then substitute angle 1 and 4 in for angle 5. So we still had the measure of angle 2 plus we put 1 and 4, measure of angle 1 plus the measure of angle 4 in for angle 5 equals 180. And then, well, we know the measure of angle 4 right here is equal to the measurement of angle 3 because they're alternate interior. So we can put measurement of angle 3 in place of the measurement of angle 4 right here. So we get this final expression, measure of angle 2 plus the measure of angle 1 plus the measurement of angle 3 all equal 180 degrees. We can also prove that the measures of the interior angles of a triangle add up to 180 degrees in another way. We're still going to start by constructing or extending side AC to be line M, and then constructing line K through point B that is parallel to line AC or line M. Once we do that, we can see that angle 2 and angle 6 are congruent because they are alternate interior angles, where line N is our transversal. And similar to earlier, when line P is our transversal and lines K and M are parallel, angle 3 and angle 4 are congruent to one another because they are alternate interior angles. And then we know that the measure of angle 6 plus the measure of angle 1 plus the measure of angle 4 will add up to equal 180 degrees since all three of these angles form a straight angle when put together. And then if we replace the measure of angle 6 in our equation with the measurement of angle 2, since they are alternate interior angles, and replace the measure of angle 4 with the measurement of angle 3, again because they're alternate interior angles, we get that the measure of angle 2 plus the measure of angle 1 plus the measure of angle 3 is equal to 180 degrees. And those are the three angles of a triangle. And they do add up to equal 180 degrees.